Assalamualaikum and hi everyone. So in this video we are going to learn about ionic equilibrium. So in this chapter there are three subtopics. 7.1 is about acid and bases, 7.2 is about acid-base titrations, and 7.3 is about solubility equilibrium. Okay, so let's start with 7.1 acid and bases. So as the learning outcome, you should be able to define acid and base according to the Arrhenius and Bronsted-Lowry theories. Identify conjugate acid and conjugate base according to Bronsted-Lowry theory. Relate pH and pOH to the ionic product of water Kw at 25 degrees Celsius. Define strong acid and base, weak acid and weak base, pH, pOH, and pKw. So this is the lecture overview of 7.1 acids and bases. So basically we are going to look at the definitions of acid and base, type of acid and base, pH, pOH, pKw, salt and buffer solution. Alright. So these are all the examples of acid and bases that are familiar around us. For examples like lemon juice, black coffee, milk, oven cleaner, soapy water, and these are all categorized as acid and base according to their pH. Okay, now let's look at the definitions of acid and bases. Okay, there are three main definitions of acid and bases according to Arrhenius Theory, Bronsted-Lowry Theory, and Lewis Theory. In this lecture, we are only going to focus on definitions of acid and base according to Arrhenius and Bronsted-Lowry Theory. Okay, according to Arrhenius Theory, acid is a substance that produces H plus or H3O plus ion when dissociates in water or aqueous solution. For example, when hydrochloric acid dissociates in water, the product form is H3O plus Cl minus. So from this equation, you can see that H3O plus is produced. That means HCl is an acid. Next is base. According to Arrhenius theory, base is a substance that produces OH ion in water or aqueous solution. For example, when sodium hydroxide dissociates in water, it forms Na plus OH ion. So OH ion here is produced. That means NaOH is a base. Next, we are going to define acid based on Bronsted-Lowry theory. Acid is a substance that can donate a proton H plus to another substance. For example, HCl plus H2O to form H3O plus Cl minus. So HCl here is an acid, so it donates its H plus to water to form Cl minus. Next is base. Base is a substance that can accept a proton from another substance. For example, NH3 plus H2O to form NH4 plus OH minus. So in this case, NH3 is a base, so it will accept a proton to become NH4 plus. Okay, now let's look at the conjugate acid-base pair. The acid-base reactions can be written in the general form Ha plus B to form A minus plus HB plus. So Ha here is acid, so it will donate a proton and it becomes A minus. So A minus here is a conjugate base. And for B is a base. So B will accept a proton to form HB plus. So HB plus here is a conjugate acid. What do we mean by conjugate acid and base? Conjugate acid is a species formed when a Bronsted base accepts a proton. and conjugate base is a species formed when a Bronsted acid donates a proton. Okay, let's identify conjugate acid and conjugate base according to Bronsted-Lowry theory. So HCl plus H2O to form H3O plus Cl minus. So in order to find the conjugate acid and conjugate base, let's look at the acid HCl. So HCl will donate a proton and HCl will form Cl minus. So Cl minus here is a conjugate base. H2O is a base, so it will accept a proton and it becomes H3O plus. So H3O plus here is a conjugate acid. Okay, another example is NH3 plus H2O to form NH4 plus OH minus. So in order to find the conjugate acid and conjugate base, let's look at the reactant base NH3. So NH3 is a base, so it will accept a proton and it forms NH4 plus. So NH4 plus here is called as conjugate acid. And for H2O, H2O here is an acid, so it will donate a proton and it will become OH minus. So OH minus here is a conjugate base. Please keep in your mind that water can act as acid or a base. Another example is HNO2 plus H2O to form H3O plus NO2 minus. So from this equation, HNO2 is acid. So it donates a proton to H2O and it forms NO2 minus. NO2 minus here is a conjugate base of acid. H2O is a base, so it will accept a proton to become H3O plus. So H3O plus here is a conjugate acid of base. Please note that the stronger the acid, the weaker its conjugate base, and the stronger the base, the weaker its conjugate acid.